Hi, I'm Paul Wheels. I'm the founder of IoT North. We've got a great show coming up with you today. I'm going to bring in my good friend John. Hi, John. How are you? You're on mute. Let me take you off. There we go.
Yeah, really good. Just started a new IoT project, which is a sort of conversion from a Windows desktop to an edge device. So that's quite exciting.
Excellent.
Been playing with lots of neural network fun, which I'm probably going to do a presentation on at some point, which could be quite nice.
That'd be really cool. Look forward to having that. Hey, talking about things that we've got coming up, would you like to talk about what we've got coming up next month with ElastiCloud?
So we've got Andy Cross, who's been before doing a presentation on how to fix broken IoT with a digital twin. So some means of visualizing your IoT assets. Using a screen plan map type thing. Sounds really good. The graphics are impressive.
Excellent. Look forward to that one. And that's going to be, as we are this month as well, we're using our new webinar feature, as well as the usual streams to LinkedIn and YouTube. Please do say hello. We've got a few hellos coming through. We've got Alexander there, and we've got Alejandro as well. So hi to everybody joining us. It's a live and interactive show, so please do fire your comments, questions across, and we will bring them into Pavel, who we have on this week. Hi, Pavel. How are you?
Hi, Paul. Hi, John. Hi, everybody. Thank you for having me. My name is Pavel Hübner. I'm CTO and co-founder of HARDWARIO. I'm pretty excited to be here because today we have exciting topic, right? We are talking about state-of-the-art operating system called Zephyr.
Excellent. Really looking forward to this, and we've already got a few saying hi across our YouTube channels as well as our StreamYard channels as well. This is absolutely brilliant. I'm going to take a bit of a backseat because I've got the dreaded bug at the moment, so I may have a coughing fit. So, John, I'm going to hand over to you to drive the show, and I'll sit in the background.
Okay, thank you, Paul. I have some small experience. I had several months playing around with the Thingy 91 that got sent to me, which is a pretty capable board in a tiny package.
Yeah.
GPS, 4G, battery, message queuing, RFID, sensors coming out their ears. Really great stuff. This was about a year ago. I struggled a little with the developer experience. So I'm really looking forward to your presentation to see how things have moved on since then.
Yes, so I hope that we will fix some struggles you had. I hope that your struggles were not too complicated that I will not be able to answer them. But what you hold in hand is Thingy 91. I think it's excellent board development kit from Nordic. Probably one of the platforms I would recommend to start with, but because we are hardware manufacturer, I will be presenting on a different one, which is actually equipped with two Nordic chips as well, and which is quite different. It's not really a development kit. It's a ready to deploy device called Chester that has been battle tested in so many use cases, and we are deploying those in large quantities all around the world.
Okay, cool. Yeah, I mean, you can run machine learning models on something like this, which is quite impressive. This arrived in the post this morning. So this is called a Nikla voice, and you can create an edge impulse model that will do audio recognition. So simple cases, if you say Alexa, it will flash a blue light, but you can do much more complicated things.
Oh, so yeah. People are doing more and more ML stuff on these tiny devices, which is something.
Yeah, it's an exciting world. I've even managed to replicate my voice using one as well. Yeah.
All right.
Watch this. Hang on.
Hello, IoT North. I have been playing with Azure Neural Voice to create a facsimile of my voice.
Yeah, so I gave it like 30 utterances of my voice, programmed it, and then now it can talk like me. So if I have a coughing fit like Paul, I can just like type away and it can be talking as if I was there.
This is really cool stuff. Maybe you can learn me something after this session. Yeah, I have no experience with these things, so yeah.
It's good. Right, so moving quickly on, we are looking for speakers. If anyone's got any talk ideas, please get in touch with Paul and myself. And over to you.
Okay, thank you. So, am I already sharing my screen? You confirm that?
Okay.
All right. Can you see it?
Yeah.
Very good. So thank you again for this opportunity to talk about this exciting topic. The name of the session is Zephyr RTOS in 1 hour, which is actually a very ambitious title. As you could have heard John, he has been struggling for quite some time. And the topic is really vast. And of course, it's impossible to squeeze all the details and corners of this vast ecosystem. But at least I will try my best to give you a very fast flyover what Zephyr is and how you may benefit from it in your next embedded project, because I believe personally that it's the operating system for microcontrollers for the future. I have been working with Zephyr for about 2 years now, so I'm fairly new in the field because Zephyr has been with us for about 6 years. And I was lucky because I had a couple of people who helped me to actually do this initial boost into the ecosystem. So I'm very grateful for that. So hello, Kaspar. you know what I'm talking about. So let's get into it. So what is Zephyr RTOS? It is real-time operating systems, and we have had many of those, like FreeRTOS, ThreadX, today called Azure RTOS. And these are all very well settled RTOSes that you can use right away. Some of them are free. Some of them come with some pricing. But Zephyr RTOS is quite different because it's not a tiny RTOS that you can think of just as a task switcher on its own. It's fairly complex ecosystem. And I usually explain people that Zephyr is a framework that leads you the way how you should actually create your application to make it very reusable, very modular, and you can basically create a code that will impose very low maintenance requirements in the future. So Zephyr RTOS was created to be like very secure operating system. Now it's actually undergoing through some safety certifications. It was designed with low power applications in mind, and it was specifically created for Internet of Things projects. So this is why we in HARDWARIO have picked this RTOS, because we are hardware vendors and we create open embedded platforms for connected projects for IoT. And it was quite natural process because we have selected previously Nordic Semiconductor as our silicon vendor because we had Bluetooth in our platform. And back then, like 4 or 5 years ago, when we chose to work with Nordic, they didn't have Zephyr RTOS really supported. But at some point, Nordic has decided to go all in to Zephyr when they released their cellular system in package called NRF9160, which supports NB-IoT and LTE-M. And back then, there was already noise around Zephyr because after those years of development, it started being very, very nice and very, very settled operating system. So it was the right time to jump into this and switch over our project to Zephyr. And we are very happy to do that. Of course, it's not that easy. Like if you, for example, start with FreeRTOS or ThreadX or some other, let's say, leaner solutions, because with Zephyr, you have some learning curve. You have to learn the way how it is structured, how you should create the application, the drivers, what are the subsystems, how to use them, and so on. So we will talk about this very soon. Next one. Yes, as I said, it's operating system for microcontrollers, but it was heavily inspired by Linux people who contribute a lot to Linux kernel. And this is the reason why they have actually probably got inspired and took many of the good things from the Linux ecosystem and brought that to microcontroller level. it's not just a community project, or well, it is open source, of course. It is on GitHub, and many people from community contribute to the projects. There are over 70,000 commits, and the pace of the committing, I have a feeling, is growing very rapidly. But it is also backed by big vendors, big players like Intel, Facebook, Google, and XP. Of course, last but not least, Nordic Semiconductor, who is one of the biggest contributor to the whole ecosystem. Zephyr targets microcontrollers, but unlike many other operating systems, they require you to run at least 32 bits. Well, most micros are 32 bits, but you cannot use 8 bits, 16 bits. It's just not supported. There are probably many architectural reasons, and I think it's a good way to be, honestly, because for modern designs, at least this is my perception, for modern projects, 8 bits and 16 bits are not that trendy, and there are so many options today to go for low-cost 32-bit MCUs. So, as I said, it's very active projects. There is a link to GitHub, github.com/Zephyr project-RTOS/Zephyr, because they have multiple repositories in there. And you have open documentation hosted on docs.zephyrproject.org. And of course, there is a homepage where you can find a lot of useful resources, links to the videos, links to the documentation, everything. I have to talk about also another very essential component, which is called NRF Connect SDK, or in short, NCS. And this is like additional layer on top of the Zephyr operating system, which was created by which is maintained by Nordic Semiconductor. And Zephyr is like the base, and NRF Connect SDK is a foundation that provides you extra support for Nordic boards. They provide a lot of samples. They, for example, create their own Bluetooth stack called SoftDevice, so they have a lot of support around it. But there are also many other stacks and protocols supported, like Thread, Matter, Zigbee, and there is really a vast ecosystem. Also, one of the measures is that Nordic, in their repositories for NCS, they have also over 13,000 commits, and they release the new version every 3 or 4 months. And they keep up with Zephyr a lot, and also Nordic people contribute directly to the main line of Zephyr. So it's a very connected ecosystem for us, because our Chester platform, which I will talk about shortly, is based fully on Nordic, and we use an NRF Connect SDK, despite in theory we are not like restricted to, but it brings a lot of benefits. So again, this project has its homepage and documentation in a very similar fashion like Zephyr project does. Moreover, the Zephyr releases, the NCS, some version, always includes documentation for the specific version of the NCS for the Zephyr and other modules that are part of this SDK. Next, Chester platform. So this is our product. This is what we work on every day. And just to briefly introduce you the hardware platform, because this is not the main topic for this evening. It's a platform for industrial IoT. It's very open. We offer it to our partners and to developers who want to build rock-solid embedded IoT applications for industrial IoT projects. You can use it for environmental sensing, for generic telemetry, for many also niche projects like digital retail and so on. The 3 pillars of Chester platform are connectivity. So it comes with Narrowband IoT and LTM, which are part of this cellular connectivity option. There is also LoRaWAN module on the board. Recently, we came up with satellite communication through Astrocast technology. There is always Bluetooth Low Energy module, which hosts the main application firmware. And there is optional GPS receiver from u-blox for positioning applications. The second pillar of Chester is extensibility. We have really vast range of hardware extension modules, which are populated from the bottom of the main board, and they define the functionality on the terminal blocks, the green guys you can see in the bottom part of the PCB. And we have a vast range of interfaces like RS485, precision analog digital inputs, all kinds of DC-DC converters, and so on. And we constantly add new extension modules to the family based on our customer requirements. This is Chester, and from firmware developer, this is the landscape. So Chester has like 3 main microcontrollers. One is for Bluetooth using nRF52840. This chip is the highest one from nRF52 family, featuring like 1 megabyte of flash and 256K of RAM. There is also from Nordic this system in package called nRF9160. John was showing that Thingy 91, which is also carrying this module. And this is LTE module, which supports narrowband IoT and LTE-M. These are part of the cellular LP1 technologies family. And on this module, we run standard Nordic's reference application called serial LTE modem. And our main application software talks to this module through AT commands through the standard serial port. It is just compiled this serial LTE modem for the specific Chester board. So there are little tweaks, but more, I would say, on configuration level, not really on implementation side. There is also LoRaWAN module from Murata, which hosts STM32L0 with Semtech chip SX1276. And again, this is like AT command modem. Just for curiosity, we also have rewritten this firmware from original Murata implementation to our own GitHub open repository, which always keeps up with the latest releases of LoRaWAN Node, which is like reference implementation from Semtech. And this is great work of Jan Janak, who is helping us in this regard. But these are, most of these guys are like, from application perspective, some sort of black boxes, which are open source, but we will talk mostly about this left part, which hosts this nRF52. All of these have SWD connector, this serial wire debug, so you can use J-Link or some debug probe to simply refresh the devices. So this is the software stack, and I'll always explain that with Zephyr ecosystem, you can layer the Git repositories sort of like onion, but with a difference that they are sitting next to each other. They are like they can be structured in a very flat folder manner. So in the beginning, we have Zephyr SDK or Zephyr RTOS. Then we have Zephyr SDK is actually wrong. Sorry about that. That should be Zephyr RTOS because Zephyr SDK is the 2 chain. Then we have NRF Connect SDK, which is the layer from Nordic. We have Chester SDK, which is open ecosystem, and another layer which provides drivers for our extension modules. It provides also the LTE stack, LoRaWAN stack, and Chester's SDK's mission is to make everything as seamless and simple as possible for our users to really create IoT embedded applications with ease and deploy them in the field. So on top of it, it's a space for our users. They can have one or multiple applications that are leveraging this ecosystem, and at any time they can bypass any part of these layers, because one of the great strengths of Zephyr is that it's very modular and it's very minimal in a base, and you have to enable the particular modules that you want to use and build for your project. What are the requirements to start with? Well, you need, of course, to be a software developer with some basic skills. At least you need one of those operating systems like Linux, Mac OS, and Windows. I really recommend getting some reasonably fast machine. It makes a really big difference if you are building your project 100 times a day and flashing. Trust me, if you do a clean build, it can take quite a bit of time to build your project. And I've seen machines that are building projects for more than 2 minutes. And trust me, this is not the experience that you want to have. Also, in our case, our users need Chester. We recommend starting with Developer Edition, a special version that is suitable for example, fast extension module replacement. You need Segger J-Link. We are now evaluating also the possibility to use other debug probes, but this is what we have good experience with. It supports flashing, debugging, and inspection through RTT console. And I always, to any embedded developer, I highly recommend to get Power Profiler Kit 2. It's my favorite tool. Again, it's this guy on the right. It's from Nordic. And you can use that to precisely power profile your hardware. And it supports current measurements from, let's say, microamps up to 1 amp. And with up to 100 kilohertz sampling rate, you can have really a nice overview what's going on in your firmware implementation. And of course, you need some editor. Zephyr does not ship with any specific IDE or something. You are free to use anything from Vim to VS Code. We will use VS Code today. But as I said, it's mostly built around command line tools, so you are free to use what you like. In terms of software, you need toolchain. Today, everything is unified for Zephyr SDK. I would call it a little bit unfortunate name, but it's a big package that bundles the compiler and libraries and many other stuff. You need CMake, a modern build generator, and your best friend will be a meta tool called West, a tool implemented in Python, which can handle a lot of things from Git repository management, which is, I would say, in this ecosystem, absolutely essential. You can use it to build your project, flash your target, connect to debugger, and also many other things. NRF command line tools from Nordic, NRF Connect for desktop. These are all essential things when you want to work with Nordic chips. Also, NRF device manager for your mobile phone if you want to interact with the device over Bluetooth. What I like as another tool from Adafruit is this Bluefruit Connect, which you can use to, for example, connect to the emulated UART link to your embedded target. And we have a few tools of our own, like HARDWARIO Manager, which is like unified iOS and Android app for interacting with the device and uploading firmware images and so on. We have HARDWARIO Monitor, which is a GUI tool, cross-platform GUI tool for interacting with the target, and HARDWARIO command line tools, which we will work with today, and they are like a nice addition to developers' workflow. West Workspace, briefly about that, it's a folder basically which covers multiple Git repositories, and trust me when I say multiple, we are talking well above 15, 20, I don't know exactly, but just to give you an idea, and you can imagine that managing individual Git submodules who have worked with Git submodules would be quite painful. So the developers from Zephyr community decided to create a meta tool called West, which will really help you to create a workspace that will keep your workspace in very synchronized state. And whenever, for example, you want to upgrade to a newer version of NRF Connect SDK, you can do that very easily just by changing one number, one revision, and called West Update, and everything will be in sync from then. We will talk about it more in detail as well. You can set up your workspace using the West init command. When you initialize the workspace, a bunch of folders will be generated. There are folders like applications, where you have usually reference implementations of the applications projects. You have boards folder with definition for your specific hardware with device tree specification. There is drivers to carry driver implementation for all kinds of chips. The DTS folder, which carries the so-called device tree bindings, essential thing to define the device tree nodes and their properties, and possibly some overlays. The include folder, which obviously carries the header files, the lib folder for generic libraries, samples, which should be perceived as minimalistic examples on how to use a very particular functionality of Zephyr or NRF Connect SDK or Chester SDK. In the scripts folder, there are some helper scripts. Nice thing is that you can create your own Python scripts that can be invoked by the West command. So wherever you are in the West workspace, you can create sort of like a plugin that can be invoked at any path if you are inside that West workspace folder. And subsys, which carries something that is called subsystems. In the beginning, when I started with Zephyr, I had no idea what is exactly the difference between libraries, subsystems. So today I explain to people that subsystem is like extended form of library or module which can carry some build options and definitions for CMake and other things. And this is something that, for example, can enable, let's say, LTE subsystem in our Chester SDK context. It will enable a bunch of modules to be compiled in the project, and also it can automatically enable required dependencies on your behalf. And finally, folder Zephyr, which, for example, in a Chester SDK folder, carries only module YAML file that defines the paths to these individual directories. So this structure, I wouldn't say it's mandatory, it's recommended. And if you look into NRF Connect SDK or Zephyr or Chester SDK, you will find it sort of similar. You can redefine it, but in module YAML, you can have this definition, the pointers to those individual folders and files. All right, what is the basic workflow working with Zephyr RTOS? So, of course, very generic. You define what your application does. You create some implementation. Then you invoke this build. You fix the compile errors. You repeat until the linkage is done, and you flash your target with command west flash. Then you can interact with the application, possibly in several ways. Today we'll be showcasing HARDWARIO console. And eventually, you can also debug your application using the West debug command. Once you are done with your development, you can deploy your application, and we always recommend setting up continuous integration tools. Actually, in HARDWARIO, we are the maintainers of what we call NRF Connect SDK Docker image, and it is available on GitHub, and whenever new version of NRF Connect SDK is released, we update it, and in the Docker file you will find basically definition of requirements and the layers which are aligned with the documentation of NRF Connect SDK. If you click on getting started, I can show that. So if you go to NRF Connect SDK documentation and you click on NRF Connect SDK tab and go to getting started, there is installing manually tutorial. You can switch to particular operating system. So because we use Ubuntu, we follow basically in the Docker file and the layers the recommended procedure here. So I'm mentioning that because it's a very convenient way on how you can also start with Zephyr. You don't have to install all the tools on your machine. You can just pull this Docker image and build some simple sample that using this Docker image very, very easily. So that was basic workflow. About the build system, I've already mentioned that it builds on top of CMake, and CMake is a build system generator. It's not a build system on its own. The default build system in Zephyr is Ninja. Ninja is suitable for definition of the build process. It's very optimized, and it's not supposed to be edited by humans. But on the other hand, it is optimized for these build system generators like CMake, and therefore Ninja is extremely performant, and it is something that is hidden for you there in the background. You are not even aware of that you are using it. On the other hand, whatever comes to the build system is defined in cmakelists.txt. You can see on the right, your project can be as simple as these 4 lines. So in the beginning, there is something you will always find it every single CMake list, definition of the minimum version. Then you are importing a Zephyr package, you name your folder, and you include the sources that you want to include to your project. So also, when you want to add some new folder, you don't have to do it always. You can use this if-def statement, and you can refer to something from kconfig. And we will talk about this in the next section. So what is kconfig? It's heritage from Linux 1.1. There was basically no change to this. It's a domain-specific language, and that allows you to define symbols. So everybody who is working with the C language knows that he usually tweaks the way how his project is built using many defines and if-defs and so on. However, if your project gets too large, the problem is that you are not able to very well maintain all the relationships, all the constraints. And Linux developers knew it because it's like reference of the vast ecosystem. So they came up with this idea of kconfig, where you can define, declare your symbols, and you can create constraints. So on the right, you have example. You can introduce something like domain Chester LED. You say it's a type of bool, so it will be 1 or 0 in the end. And your kconfig option can depend on other symbol. So you use depends on something. Also, when you enable this Chester LED symbol, you can automatically select some other systems that are dependent on it. So select word is very important, because you can do it either through kconfig when something is enabled by the user, something else will be automatically included in the chain. But user usually defines that in a file called prjconf. So it's a very simple file, value equal or name equals value. So it would be like config ctrlet equals to yes. And that means that this symbol will be enabled, and as a result, the others will be. So you can also put some constraints about values. It can be integer. You can also like make a constraint that this symbol will be only enabled if some other symbol is within a specified range, and so on. It's quite flexible. It has some caveats, but I cannot imagine that such thing like Zephyr could actually exist without kconfig. So these are the ways like how you can check for options in your code. Either you can use it via preprocessor if config underscore something, or in the code if you need to put it in if evaluation statement, you have to use is enabled macro, and in the brackets use the name of the symbol. The kconfig is evaluated before the actual build process. As a result of kconfig, you will have a file that is generated for you, which is called autoconf.h, which you will find in your build folder. And there is always just one folder populated during the build. And in there, you can inspect what was the result of composition of all the kconfig rules and all the options that have been set up in the project. Next, very crucial subsystem is called device tree. So it's a heritage from Linux kernel, again, domain-specific language. You can define your so-called device tree nodes like peripherals in such a DTS device tree specification file. Here is the example. There is accelerometer, which is sitting on I2C bus. You can define its I2C address. You can, for example, map its interrupt pins to your GPIO pins of the microcontroller. And why is device tree great? It allows you to separate hardware definition from the actual implementation. So again, something that allows you to make more modular, more, let's say, multi-platform project that is very easy to maintain. There is an example how you can bind the so-called references. And I have to tell you that device tree is something which is, yes, inherited from Linux, but it's very different in a way that it's a static thing that will disappear during build time. So there is no runtime overhead. You define such a device tree specification file. It is again pre-processed before the actual build. As a result, there is a file called device tree unfixed, and you are using such macros to get a reference to a specific instance of the structure that can be used by the drivers themselves to, for example, gather all these bindings, all these properties that are defined here within that node specification. Again, I could speak quite more about this, but we don't have time. And I just wanted to highlight that device tree is a very unique feature that you don't see with any other real-time operating system in the market. So Zephyr fundamentals, of course, you have all these traditional things like APIs for creating threads, timing APIs. There is something quite special. I will make a note about these work queue threads. For example, when you fire up the interrupt, of course, you cannot do things like mutex locking and so on. The great example for this is timers. Zephyr has great API for timers. When you set it up and the timer timeouts, suddenly you are in interrupt context. And sometimes you need to defer the execution to non-interrupt context. And this is where work queue threads is a really neat idea. Essentially, it's like a traditional thread in the background that has a queue. And by submitting a work, which is a definition of some function, will be scheduled to the queue and will be executed. In Linux kernel, it is something like bottom-down handler, and exactly serves the purpose to defer the execution to a specific queue. There is either a system work queue, or you can create your own work queue with your own stack. Of course, it's a thread, so it has its own stack size, and you have to treat it like that. There are also services for atomics. There are standard synchronization objects like mutexes, semaphore signals. There are a lot of mechanisms how you can pass the data from FIFO to pipes. Pipes are brilliant because it's like FIFO, but you can actually do blocking calls on FIFO. So it's excellent tool, for example, if you want to pass data from your UART interrupt to a thread, to a consumer. The consumer can be basically blocking in the thread. And there is also message queue. So this is like one of the most basic synchronization examples. And of course, you have some lower level mechanisms like ring buffers. You don't have to implement your own. And there is a really cool mechanism like kpoll. If you want to synchronize your thread from multiple sources, like let's say that you have two message queues and you want to wait in your thread for any message that will appear in either of those two message queues. So you can set up this kpoll queue, and that will signalize, you will fill up the structure, the array, with pointer to those message queues, and kpoll will wake your thread when any of the events or any message has been received to those message queues. So this is another great feature that I haven't really seen in any other RTOS. Of course, for mutex services, you always have to be careful. This is something that no operating system will solve for you. It's deadlock pitfall. Yeah, everybody knows what is deadlock. So you have to really be careful about the order of locks if you have more complex applications, and you should structure your application in a way that you will not end into this. You have nice K-timer API control. I've already mentioned with this remark that you are in interrupt context if timer expires. The way how you handle critical errors is, well, I like if there is something really critical, you can call a special function called k-oops, which will dump for you in the log file quite a bit of context that will help you in debugging. And of course, anytime you deploy your embedded application, you should enable watchdog so you can recover from such critical errors, which would otherwise stuck the execution. There are some useful tips and tricks. I would say from this slide, I would highlight always check autoconf.h to be sure what is the outcome of your kconfig. And where you will find the build artifacts in the build folder is zephyr.hex or bin. These are like the files that you can share to somebody who can use the programmer to flash it. Of course, you can also use Zephyr ELF, which includes also sources, for example, for debuggers like Seger Ozone. And if you are building your project with debugger, you should use the files called merge.hex and update bin if you want to share it via Bluetooth Low Energy. So I will also stop basically this intro to Zephyr with mention to 3 key subsystems. One is logging. Logging is great in Zephyr because you can define log module on module level. You can give it a name, and you can define different log levels to each of the modules that you have in your application. So this will really help you to squelch, to suppress the logs that you are not interested in. You have also traditionally 4 levels: error, warning, info, and debug. And logging supports full printf style formatting. And yeah, it's something that usually you will mostly debug with. Honestly, I don't use debugger that much with Zephyr. I very rarely start with debug command because all my debugging mostly goes with logging subsystem. And I forgot to mention that logging can support multiple backends. So you can define UART, you can use Bluetooth, you can also use RTT, which we will be using because with RTT you can only use J-Link and you don't need any other hardware channel. So it's all there and has very, very low overhead on your code execution because you are basically just copying from memory to memory. All right, next subsystem is shell. Another great feature of Zephyr because you can have like almost like Linux-like shell on your MCU with very little overhead. Again, supporting multiple backends like Bluetooth, UART, RTT, and so on. And it's very easy to define your own shell commands. There are some built-ins, but you can use very simple macros to create your own. Last subsystem I will be talking about is settings. Real IoT projects, they need to store the user's parameters somewhere, and settings subsystem has it all solved. There is like key value type of storage with multiple options for the backend file system. So with the least overhead, there is something called NVS, non-volatile storage subsystem in Zephyr, which can sit in your internal MCU flash memory. But there are also more advanced options like little FS, where you can also store your files. And little FS is a very robust file system with which can survive power failures and so on. And the nice thing is that you can switch over between these backends for settings, again, just by configuration. You don't have to essentially deal with the implementation. So this was it. The basic highlights of feature, basic tour of Zephyr. Of course, it's way more complex. There are so many more things to talk about, but this would be out of the scope for today's presentation. But let's now get our hands a little bit dirty and let's try something. So I will switch over to VS Code. And no, not really. I will switch over to Power Profiler Kit. It's a tool from Nordic. On my table, I have Chester Development Kit. I've got J-Link and PPK, the Power Profiler Kit, connected to my machine. And here, this is the Power Profiler Kit user interface, where you can define the target voltage. You can enable and disable the output, and you can define sampling. So now I need to power it up. It's already done. I can just disable and enable. I can see that my target went on. And the first thing we will do is to build application called Blinky. So it's like hello world for microcontrollers. So let's do that. But I will not show you the blinking of the LED on the camera. Rather, I will show you how LED blinks in the Power Profiler Kit. So I will clean up my build. This is my workspace. You can see I'm in the samples directory. There is Blinky. And when I call was build, the build folder is locally generated for me. Before we flash it, let's explore this application a little bit. There are only very few files that you need in your Zephyr application to make it work. You need prgconf, where you define some default options. And we have introduced this config Chester something symbols that make it really easy for developers to enable some particular subsystems. So here we are enabling button, some default values for the system. In general, we enable the LED subsystem, the logging, and the shell. We have mentioned those two just a little while ago. So this is just one line to enable this to your application. Then you have CMake. You have already seen this in one of those slides. So 4 lines to make your project build. And there is SRC folder, which is only one main.c files. So here you can see some Zephyr includes related files. We register a logging facility with the name main. And in the beginning, when our program starts, we print the build time, and in infinite loop, we control the state of the LED, and we do so every 500 milliseconds. So every 500 milliseconds, we toggle the LED, the channel red. So we have built the application. Let's try it. Let's flash it. So now we have flashed into it something that has been generated before. You can see that there was this L file. Of course, we are flashing the hex file now. You will find the hex file in the build/Zephyr folder. There is something called zephyr.hex and zephyr.bin. I was talking about kconfig, which was processed before the build. And you can also explore that in the include directory in autoconf.h. And here you can see vast range of kconfig options that have been translated to this header file. And this header file, autoconf.h, is injected to each and every single C file that is built in your project. So you don't have to include anything special. It's ready for you, and you can just use preprocessor or this is enabled macro to check for its existence. Also, you can use this on CMake level. So if you want to make your project modular, you don't have to always build all the modules in it. You can use this if-def statement on CMake lists txt level as well. So we have flashed our target, and now I will switch over to this terminal. and I will launch something we call HARDWARIO Chester App Console. Sorry. And here we can see that we are printing this a live message. On the right side, I have logs. On the left side, I have interactive console, and I can start with command help, and I can see a few options. This shell subsystem has tree-like structure, so I can use command kernel. It offers me more commands. I can, for example, do kernel threads to see which threads are there. You can see some threads are for RTT login subsystem itself. There is logging, there is main thread, and there is default system work queue that I can use for my deferred tasks. Also, I can do things like kernel uptime, which will tell me in milliseconds for how long my application has been running. If I go back now to Power Profiler Kit, because you don't see the LED blinking like I do, you can start this sampling. And here you can see the current profile in time. I can stop it. I can see what is the power consumption of the LED when it's on. I can also see when it's off. And you can see that it's at 2 milliamps. That's because right now my HARDWARIO console is running and it's keeping the microcontroller in debug mode. If I quit it, you will see that now it's a little bit lower. I can start it back. And for example, I can use this LED switch green on command to further increase the power consumption. So now my green LED is steady on, and next to it, the red LED is blinking. All right, so this was one demo. We have basically presented this power profiler. We have explored the code, flash it. We have used the HARDWARIO console, and yeah, I haven't talked about those shell commands that you can define on your own. So in Chester directory, we have the reference applications folder. I will, for example, show this Chester Climb, which is like a ready-made project, which our partners can use for environmental sensing in general. And inside Chester Climb application, I have this application shell file. And in the end, I'm defining my custom shell commands. So, for example, if I want to define command called send, I will just define some help text, name of the command, and reference to a function that will be executed when user launches that. So we can see the footprint of the function comes with the reference to the shell instance, and also something most C programmers will be familiar with, argument count and argument like list. And either you can parse it manually or even use standard libraries for command line parsing, and you can like do whatever you like on shell level to retrieve the information, the parameters the users could have passed, and process it and print back using these shell error or shell print commands. Give back the feedback to the user. So that was it, the part of the first demo. Next, we could, for example, try Bluetooth. And for that part, I will use this hardware that I have now in my hands. This is that Chester Climb product that we have, that we can provide out of the box. And inside this Chester Climb unit, I have running firmware, our catalog application, that has Bluetooth enabled. And what I will do, I will start screen sharing to my cell phone. So I will start this application called Screen Copy. But beforehand, I should connect my cell phone to the PC. All right, I'll allow USB debugging. I like that. And we can start the screen copy. So now you will see my Android screen, and I can start our application called HARDWARIO Manager. And you can see in our lab there are a lot of Chester devices, and on the Chester device we have a QR code from backside, and I can use this scan QR code to connect to my device. And here you can see the basic parameters of the application, like firmware version, hardware revision, and many others. You can also see that device uptime is 1 day, 1 hour. And here in a menu, I can open terminal and use basically the same commands as I'm using with my RTT buffers in HARDWARIO console that I showed a little while ago. So you can do exactly the same things in your mobile app. And the funny part is that getting all this functionality in Chester SDK is just by enabling one single line in prj.conf. So if I go back to this real application Chester Climb and I open the prj.conf, there are a bunch of options, but only this one is responsible for enabling Bluetooth ecosystem. But not only that, you also get with it the capability for firmware updates. So here in the menu, if I go back to this mobile phone, I have also update firmware possibility. I can scan the QR code of our firmware, which we generate for the users when they deploy the built firmware image using Chester SDK, and they can easily transfer that image on their device without dealing with any hex files, bin files, whatever. We have made really fluent experience for the developers to make fast deployment that is easily shareable with our customers. All right, so that was the Bluetooth demo. Bluetooth is really advanced topic in Zephyr, and thanks to Nordic, they have contributed a lot and make it a very, very robust solution for the users to integrate this technology. Also, it's pretty simple to create your own Bluetooth so-called GUT characteristics, like the sockets through which you can communicate in your app. In Zephyr, it's as easy as creating a macro where you define a service, Bluetooth GUT service, and GUT service covers like 0 to n Bluetooth GUT characteristics, and characteristic is like the socket which can read or write or can even notify, and you can just define the callbacks for reading and writing, and in those read-write callbacks you process the request and either provide the data or you set it back to your application. And so again, Bluetooth is absolutely amazing in Zephyr, and I couldn't imagine that I would implement Bluetooth stack anywhere else after this experience. So yeah, it's actually exactly 1 hour, and let me do another quick demo, because this was the promise of this webinar, to also see how such a Chester platform equipped with cellular connectivity can easily get your data to the cloud. So now I will reconnect my J-Link to this Chester Climb unit that you have seen a little while ago. I will open the Chester console. So I will quit this screen copy app and open the console. So now I'm in the Chester Climb app. I can type info show. So yeah, firmware name is Chester Climb. And here I can do a couple of things, like I can, for example, read the onboard thermometer. The result is here. I can also read, I can read hygrometer, so you get temperature and humidity. What we do in a Chester Climb application is that we have configurable sampling interval, aggregation interval, where we calculate average, median, minimum, and maximum values. and configurable report intervals. So these buffered aggregated calculations are at regular report intervals sent to the server over NB-IoT technology. We have created a layer called config, and you can use command config show to dump complete configuration of your device. So you can essentially share these lines that were flashed here. And with these lines, you can back up your configuration and revert it back if needed. And you can see there are these 3 configurable intervals. Also, you can immediately trigger transmission. So if I type command send, you can see that the magic will happen on the right side, and there will be this AT command to the modem that will send arbitrary stream to HARDWARIO Cloud. HARDWARIO Cloud is a very optional part for HARDWARIO, but most partners use it because it's absolutely convenient to retrieve JSON data using REST API or deliver JSONs to user-defined endpoints. So let me open that, and I will open the organization HARDWARIO test panel, where I have these Chester Climb devices. This one has serial number 9024. If I go into it, you can see the newest messages on top. And if I unfold the message, I can see JSON. Of course, if you calculate the number of characters in the JSON, it wouldn't be these, 296 bytes. No way. So what we do, we serialize the data stream that we want to send to a format called CBOR. CBOR stands for Constraints Binary Object Representation format, and you can perceive it as something that can actually encapsulate JSON-like structure, but in a much more efficient way. Some people may know MessagePack. Well, this is actually really similar to MessagePack, but CBOR fixes a few design flaws in MessagePack, and it has been standardized, and we use it. Of course, we are not transferring these strings in CBOR. We could, but what we do, we replace the string fields or string keys with integers, and we supply to our HARDWARIO Cloud backend something what we call codec that can translate from these integers back to the string keys. So of course, there is a little overhead to CBOR, but that is a penalty that you don't have to develop a specific parser, a specific microservice for an application that you have just built with Zephyr. You define all the structure on application level, and it's quite straightforward. It's copying the JSON structure. So if I go to Chester Climb source and open up CBOR, up CBOR.c, here you can see that in that serialization function, I'm putting in the particular keys of that tree and inserting those individual fields. And because I'm using that enum that is generated from a YAML file defined in this codec, and we are using a script that is part of our Chester SDK to translate that to message key.h, which you are later using in that appcbor file to serialize the data stream, you are very, very efficient in terms of data transfer. So this is our mission. We basically create this ecosystem to make it really easy to go from a sensor up to the cloud to this JSON message and create all the foundation to run robust availability for these data streams. So I guess that was the main part of the demo. Yeah, and yeah, I'm stopping my screen sharing and handing over to the studio.
Thanks, Pavel. That was a super fast, super high level tour of Zephyr. You covered
Thank
a
you.
lot of ground there.
Yes, we work around the clock, and we are seeing some good successes with our partners who are already, with our help, able to build their own application. And yeah, it's always about long run. As you said, John, it takes a bit of time to get your head around it. And yeah, this is what we are helping our customers to do and educate them with this Zephyr ecosystem, because we feel it's pretty solid. We can feel also that really super active process on Zephyr side and Nordic, and all the commitment and contributions to the whole ecosystem. And we just like to be part of it. It feels like very innovative technology.
Cool. Just waiting for questions. If there are any, please put them in the chat. In the meantime, the thing I struggled with was, let's say I want to use the RFID reader on there. Yep. Now, if this is Arduino, I'd go file examples RFID, and I'd be taking RFID samples and programming them from a device in less than 60 seconds. The thing with NOFF Connect, okay, it's a good package, but there was a lot of layers to it, and it's not obvious where you're going, where to start, and all that. So, yeah, I see there's a lot more learning curve.
Absolutely, I agree with you, John, and especially when you are really starting out, it may feel very daunting, and it is very helpful if you have somebody that you can go to and ask. And I didn't have that in the very early stage when I was starting out with Zephyr. So it was a lot of trial errors attempts, but now the situation is way better, and we are providing such trainings. What I have squeezed today in 1 hour, I usually run in like 6 hours sessions to our customers.
Yeah.
And yes, once you have that initial boost, once you see that there are reference implementations and samples where you can get your inspiration from, and you can try, build them, flash them to your application, and you have the opportunity to go and ask somebody, it's very helpful with Zephyr.
Okay, cool.
And on the other hand, the situation is getting much better. Or when I was starting about 2 years ago, when I was Googling out some Zephyr API calls, very often I ended up only with single response in Google search, and that was the Zephyr documentation. So these were the early days of Zephyr, I would say. But we can see a lot of open source projects popping up. Just last week, I have registered this open source Zephyr smartwatch project. And yeah, it's called ZS Watch, and I really like it. Somebody just for fun created open hardware.
It doesn't look like that, does it?
It's actually, you know what? It's not that big, but it is 3D printed and it's completely open. But I love the idea, and these are exactly the types of project that will make it more accessible. And
cool. There's a question on the screen. Dig Wallace. Some indication of cost, please.
Oh, well, so speaking of the Zephyr itself, of course, it's for free. But speaking of the development platform for Chester, that is like $250, like the basic price for the platform, where you have cellular connectivity, LoRaWAN module, Bluetooth module, and all this kind of stuff. You can find the description on hardwario.com/Chester. We are now about to start selling those things also through Amazon, but it's already available today on eShop. And let me actually take the opportunity to share the screen again, because after this demo slide, I had another one which talks about this dev kit. You can find it at shop.hardwario.com/Chester-dev kit. And we have actually set up 20% discount if you use voucher IoT North. and the voucher is valid until Sunday, February 12th this year. So if you really want to get it, you start there. And I believe it's very different development kit in a way that, yes, you can use it as a dev kit that has full C and FCC certification, but you can also put it in IP67 waterproof enclosure. You can use such lithium ternary chloride battery, this primary lithium cell, to let the Chester device operate in the field for years. Of course, depends on the specific use case, but we have some applications where we have estimates for 3-4 years lifetime easily, and can be even prolonged if you reduce, for example, the transmission interval.
And what sort of applications is it being used for at the moment?
Oh yeah, so the main applications, as I said in the beginning, it's industrial IoT scope, and we have use cases mostly like machine monitoring. So typical use case is that the manager in the production floor wants to monitor, for example, power consumption of the machine. So we have this reference implementation called Chester Current with these non-invasive current probes. And it can be easily hooked to the machine and observe the current consumption. Another one is Chester Push. If I actually go to our documentation, there is a section called Catalog Applications. And Chester Push is a device which has, I can show it also on the camera, for illuminated RGB push buttons. And these can immediately notify about some event when, for example, machine gets broken. Also, we have this Chester Climb for environmental monitoring, not just temperature and humidity. We can also sense CO2, barometric pressure, noise level, and other stuff. We've got Chester Scale for measuring precise weight scales, interfacing these, load cells. And we have a nice use case from retail industry where we were observing the weight of the goods and could notify when the goods was about to be refilled. And plethora of others. We have customers in the UK, in Vodafone. We have done this project for environmental monitoring on the trees, and we were observing the tree growth and correlating that to change and impact of the environmental changes. And I would say that Chester can be used anywhere where it's not really consumer oriented. You can see that the enclosure itself is not super small. It's like 130 by 170. But to many of these applications, this is not a limit. And with this extreme extensibility and so many industrial interfaces, it can be used, I would say, in infinite amount of applications. We are always discovering new possibilities for this. And we have like several models. Either you get a Chester dev kit and you can develop your application from scratch, or you will use one of our reference applications. And today we have like about 7 of these. Not all of them are documented. Documentation is a big effort now in HARDWARIO, and we are adding like every 2-3 weeks a new article on the reference implementation. And in the reference implementation, you can find anything about configuration, specific command, reference JSON message, and so on. Of course, the generic application behavior. And as I said, catalog applications are part of Chester SDK, like open implementation. So many of our customers, they take it as a reference. They, for example, extend it, tweak it, change it, and they don't have to start from scratch. Or, of course, we in HARDWARIO provide like complete end-to-end solutions where customers specify the requirements. And yes, they still hold the sources. We create a specific GitLab repository for them, provide access, but we develop in-house the specific application. Of course, our long-term dream is to be really platform-oriented and have more customers who are able to individually develop their own applications and implementations, and we are supporting them through our forum, through enhancing the documentation, and of course continuous maintenance of our Chester SDK and synchronizing with the upstream NRF Connect SDK and Zephyr. So yes, this is
another question. Can we have access to the slides? I think that'd be quite useful given the amount of ground you covered. If you could do
yes,
that.
absolutely. So I will share with you, John, the slides if it works.
Yeah, we'll tweet them out on IoT North U, Twitter channel. So,
all right. So
yeah,
maybe after this session, I will just discuss with you how it's the best way to share the slides with you. All right.
Yeah. Okay. We'll put them on LinkedIn as well. Cool. Thank you for that, Pavel. That was fantastic. If there are no further questions, Jose says thank you very much.
Hi, Jose. Yeah, he's our friends actually. There's another guy, Jose. So really pleased that you guys have joined. Thank you so much for your support. And yeah, thank you so much for the opportunity to talk about Zephyr. It was in the last slide. There are 2 opportunities where you can meet us. So we will be present at the Zephyr booth in Embedded Vault in Nuremberg next month. So you can meet us there. It will be like March 14 to 16. So yeah, meet us in Nuremberg. It's a great event for any embedded engineer. I highly recommend that. I haven't been there myself for years. And there is another exciting news. Zephyr community has decided to hold a Zephyr Developer Summit this year in Prague, in our capital. So, of course, we want to be there as partners. It will be in June 26 to June 30. So, yeah, two near-term opportunities to meet in person and discuss, and also look at Chester Dev Kit. So, yeah, hope to see you there. And thanks to IoT North. Thank you again for this time.
Thank you.
And, I hope you guys enjoyed it. We will share with you all the materials, the slides, and I will be happy if you are back in touch. In the slides, you will find my email. And if you are interested to get into this ecosystem and start the journey with us, we will be happy to do so, and we can schedule a conf call and continue the conversation. So thank you again, and see you soon.
Thanks, Pavel, and look forward to catching up with everybody next month with ElastiCloud and Andy Cross. John, thank you for the stellar work as always in supporting and help organizing the events. Don't know what I would do without you, so thank you, my friend, and see you next month.